All right, let's just jump right in. For as long as there have been markets, people have been trying to predict them. I mean, it's the ultimate forecasting challenge, right? But what if the secret isn't just about what's happening today, but about remembering things from the distant past? We're about to explore how a very specific kind of AI is being built to do exactly that.
And this right here is the heart of the entire problem. The market remembers the dot-com bubble. It remembers the 2008 crisis. Every single boom and bust leaves a scar. The real question is, can we actually build an algorithm that remembers it too?
So that brings us right to our first big topic, the market's memory problem. We're calling this one the ghost of data past, because really, the influence of old events is kind of haunting every single new trading day.
It really does seem like a simple question, doesn't it? But wow, the answer is anything but. It's not just one thing. It's more like a perfect storm of different factors that makes this whole forecasting thing so notoriously difficult.
You can really boil this chaos down to 4 key challenges. First, financial data is just noisy. The real signal you're looking for is buried under tons of random, meaningless fluctuations. It's also incredibly volatile. It can be dead calm for months and then pure chaos for a week. The relationships are also nonlinear, which is a fancy way of saying A plus B doesn't always equal C. And, maybe most importantly, it's non-stationary. The rules of the game are always changing. A strategy that made you a genius last year could be completely useless today.
So the first logical step for AI researchers was to use something called a recurrent neural network, or an RNN. And on paper, it seemed perfect. It was designed to handle sequences of data, which is exactly what market data is. But it had this critical, fatal flaw. It was forgetful. It had a bad case of digital amnesia.
And here's the technical reason why. It's a mouthful, but it's called the vanishing gradient problem. Think of it like a game of telephone. As the model tries to learn from an event that happened way in the past, the importance of that information just shrinks and shrinks with every step it takes back in time until it's basically zero. The ghost of data past literally vanishes, and all the RNN can remember is what happened like yesterday.
So how do you solve amnesia? Well, you invent a better brain. And that leads us to our second section, the LSTM. That stands for Long Short-Term Memory Network, and it was designed from the ground up to have an active, working memory.
And to really get a handle on the LSTM, there's this fantastic analogy that calls its core a memory conveyor belt. Just picture that, a separate little highway for information that flows right through the network, totally protected from the decay that killed the old RNNs. It's built specifically to carry important memories over very long distances.
So this is the real game changer right here. It's the shift from a passive memory to an active one. An RNN's memory is just a passive echo that's doomed to fade away. But an LSTM, its memory is like a little database manager. It actively learns and decides what's important enough to remember, what's junk that can be thrown away, and what needs to be updated.
And it does all this using this really clever system of 3 gates. Think of them as little bouncers. First, the forget gate looks at old memories and decides what's no longer relevant, like when a bull market finally ends. Then, the input gate looks at all the new information coming in and decides what's important enough to actually store. And finally, the output gate looks at everything in its memory and decides what specific pieces it needs to make a prediction right now. It's this constant, intelligent process of managing its own memory.
Okay, so that's the theory. Let's see how all this abstract stuff about gates and cells actually translates to the trading floor. We're going to go from theory to the real world.
Because an LSTM can actually remember things for a long time, it can start to learn patterns that unfold over months or even years. It can spot the lingering effect of a Fed decision, or that old Wall Street saying that chaotic markets tend to stay chaotic. It could even track the slow rolling waves of investor sentiment from news articles, or see the long-term health trend of a company from its earnings reports. These are the kinds of signals that are basically invisible to any model with a short memory.
But check this out, because this is maybe the most crucial takeaway. You might think the whole point of this is to predict the exact price of a stock, right? But look at how LSTMs are actually used.
A whopping 60% of the time, the real value is in forecasting the direction. Is the market generally going up or down? And another 30% is for volatility. Is it about to get crazy or stay calm? Predicting the exact price, that's only a tiny slice of the pie.
Of course, the LSTM isn't the only tool out there, not by a long shot. So that brings us to a little battle of the bots, where we can see how the LSTM stacks up against other powerful models.
So compared to classic financial models like ARIMA and GARCH, the LSTM is a completely different animal. ARIMA is simple. It's easy to understand, but it just falls apart when faced with the market's complexity. GARCH is fantastic for predicting risk and volatility, but has no idea which way the market is actually headed. The LSTM can handle all those messy, nonlinear patterns, but the trade-off is that it's a beast to run and it's famously a black box. It's really hard to know why it's making its decisions.
And what if we compare it to another giant from the machine learning world, like XGBoost? Well, the key difference is how they see time. An LSTM is built from the ground up for sequential data. It just automatically understands the order of events. XGBoost, on the other hand, is lightning fast and powerful, but you have to manually teach it about time. You have to create features like, what was the price 3 days ago? It's just a totally different way of looking at the problem.
And the evolution never stops, does it? The new kid on the block is the transformer model, the same tech behind things like ChatGPT. While an LSTM plods along, processing data one step at a time, a transformer looks at the entire history all at once. This makes it way faster, and maybe even better at spotting those really long-term connections. The battle of the bots is always changing.
And now we've arrived at what might be the single most important part of this entire explainer. We've talked about all the power and potential, but now we have to talk about the perils of prediction and the hidden traps that are waiting for you in the world of trading.
Think of these as the three horsemen of the quantapocalypse. First is overfitting. This is where your model doesn't learn, it just memorizes the past, noise and all. It becomes a genius on old data, but it's completely useless for the future. Then you have regime shifts. This is when the entire personality of the market changes, and your model, trained on the old rules, just completely breaks down. And finally, you've got the black box problem. When your magic box stops working, you have absolutely no idea how to fix it because you never really knew how it worked in the first place.
And that brings us to the most dangerous trap of all, data snooping. I love the phrase for this. It's when you torture the data until it confesses. If you test thousands of random ideas on old data, I guarantee one of them is going to look like a genius strategy just by pure dumb luck. You haven't found a real signal, you've just found a random pattern in the noise, and that strategy is guaranteed to fail the second you use real money.
So what's the answer? The crucial point is this. The solution isn't to just build a bigger, better, more complex model. It's to build a more disciplined process. It's about having brutally rigorous testing methods, constantly retraining your models as the market evolves, and using amazing new techniques from a field called explainable AI to finally crack open that black box and understand why it's making the decisions it's making.
Which, leaves us with a final, really fascinating question. As these AI tools get more and more powerful, is the future of trading just going to be a high-speed war between competing AIs? Or will the real advantage go to the people who can build a true partnership between the incredible pattern recognition power of the machine and the judgment, intuition, and wisdom of a human expert?